I hope you have solved the questions from the previous lectures. There we have discussed calculation of entropy changes uh, for different thermodynamic processes. So we have discussed for questions of type 1, type 2, type 3. Okay, so this question is also of type 3 because you can see this is all about change in entropy of an ideal gas. And here the beauty of this question is that for solving this question you should have a strong understanding of first law of thermodynamics for work done calculation and heat calculation, right? Then only you will be able to solve and you will be able to understand this question. I will try my best to explain this question, but it is prerequisite prerequisite for this question so that you have a solid understanding of this work calculation and heat transfer calculation from the first law of thermodynamics. And this question is very important for your exam. So now let's try to attempt this question. So it is given 1 kg of ethane gas. So just write it. M is how much? 1 kg. 1 kg of ethane gas is compressed from P1 is 1.1 bar, T1 is 27 degrees Celsius. According to law, PV की power 1.3 is constant. So here we have pressure, here we have volume, right? And what we are doing, it is compressed from 1.1. So you can see this is gamma is 1.3. so this will be what polytropic process. So polytropic process or adiabatic process, it travels between two isotherm, right? So the process will be like this. Let me make it by different color. It is compression is taking place, so this will be what, 0.1. This will be what, 0.2. okay. 1 kg of ethane gas. So let's come to main question. So here we will get P1 corresponding to this state and P2 corresponding to this state. So we have P1 is given, T1 is given, and it is this is following PV की power 1.3 is constant until the pressure is P2 is 6.6 bar. Now you can see that during this compression volume is decreasing and pressure is what, increasing. Calculate the heat flow, okay. And this is what n value is given, 1.3, n value is given 1.3, okay. And this is for ethane gas. So for ethane is what, CH4. So carbon 12 plus hydrogen is ethane, sorry, this is what, methane. Now what is the chemical formula for ethane? Okay, so this will be, ethane will be CH3. So for ethane, just for your recapitulation, methane is like this. This is CH4, and ethane, in ethane we will have 2 carbon chain and other will be hydrogen. So this will be what? C2H6. Okay, so molecular weight carbon is 12, तो 12 दूनी 24 plus hydrogen is 6, 24 plus 6 is 30. So this will be what? 30 gram per mole. Okay, so I'm removing this section. Okay, so now let's try to calculate what it is asking. Calculate the heat flow. Calculate the heat flow to or from the cylinder wall and entropy change. Okay, so we know that heat flow कैसे calculate किया जाएगा यार. Heat flow from यहाँ से यहाँ बोल रहा है, right? So let's write the first law of thermodynamics. So how we were writing that dE equals to del Q minus del W. Okay, अच्छा. Now let's see पॉलीट्रॉपिक प्रोसेस के लिए वर्क डन कैसे निकालते थे हम लोग. So how we were calculating for polytropic process, I hope the formula was P1V1 minus P2V2 upon n minus 1. This was the formula for polytropic work done, right? And so this value, so is it given? V1 V2 is given here. Let's check. V1 V2 is not given here. Okay, now if I apply PV equals to MRT1 and MRT1 is given here. Yes, T1 is given here, and is T2 is given here. T2 is not given. Okay, if T2 is not given, is there any possibility that we can find the T2? Okay, yes, we can find the T2 from this relation, or you can find V1 also from this relation. Anything you can use. So I will be taking the relation between P and T for point 1 and 2, and we will calculate the value of T2 for this point, right? Now let's try to first calculate. अगर अच्छा T2 मिल जाएगा तो मुझे क्या होगा? Then we will get the value of work. And how we calculate dE is equals to du. This is what change in internal energy. This will be mc dt. Okay, so this will be what we will get from here. Otherwise we have one specific formula for this heat flow in polytropic process. That was what? Just write that formula and you will directly get the answer. Okay, so you can write that formula. That was some times of W, but here we need to calculate T2 for calculating the entropy change. That's why I am using the longer form. I am using the longer route. Okay, now let me remove these things. Okay, so now let's try to calculate first this temperature value. So we know that P1 V1 is equals to P2 V2 की power n. So from here we will get T2 by T1 is equals to P2 by P1 की power n minus 1 upon n, right? If you do this, you will get T2 as 453.74 Kelvin. So make sure guys, this calculation you have to do by yourself. If you are getting stuck in this problem, then just message me or you bring your calculator to me. I will explain how to solve this. Now you will get T2 value from here. Now work done in 1 to 2, this will be how much? P1 V1 minus P2 V2 upon n minus 1, right? So this will be what? Now use P1 V1 equals to mr T1 minus T2 अपॉन n माइनस 1। अच्छा यार, अपन को r की वैल्यू पता है क्या? r इज़ व्हाट? कैरेक्टरिस्टिक गैस कांस्टेंट। इसकी वैल्यू कैसे निकालेंगे? दिस विल बी यूनिवर्सल गैस कांस्टेंट अपॉन मॉलिक्यूलर वेट। दिस विल बी 8.314 kilojule per kg Kelvin, and this will be, just put it simply here, 30. We will get, let's do this calculation, we will get R as 0.2771 kilojoule per kg Kelvin, right? Now put here, and m is given as 1 kg. Small m is the mass of the gas. So now put all the values here. M is 1, R is 0.277, T1 is how much? T1 is 270, then add 273, you'll get 300, right? 300 minus T2 is how much here? T2 is 453.74 Kelvin, just divided by n minus 1. n की कितना है? n is 1.3 minus 1. Do this calculation, you will get work value as 141.88 kilojoule. This is what work value. So you can see here this work is coming out as negative. What does it means? That is, work is done on the system, that is, work is done on the ethane gas for bringing it from position 1 to position 2. Okay, now let's try to calculate change in entropy, change in internal energy. So this will be MC T2 minus T1, MCV T2 minus T1, right? Now it is important to know that how we will calculate the CV value. So here small m will be 1 kg. CV, we know Cp minus Cv is R, and Cp is given in your question. Cp will be given in your question during the exam, and Cv we can calculate from here. So if you calculate R value is how much, we have to take this, calculate Cv, we will get 1.47, we will get 1.473, and do T2 minus T1. T2 is 453.74 and T1 is 300. Just do this calculation, we will get change in internal energy as 226.16 kilojoule. Okay, so now from first law of thermodynamics we were getting du equals to del q minus del w. So we want to calculate del q. This will be equals to du plus del w. So du will be how much? 226.16, and del w will be what? This will be minus times 141.88, right? So just do this calculation, we will get 84.273 kilojoule. This is the total heat transfer. Calculate the heat flow to or from the cylinder. So this is the total heat flow. Heat flow is positive, it means it is coming inside the cylinder, right? If it will be negative, then heat will be flowing from the cylinder, right? Now this is the one aspect, and now we have to calculate the change in entropy. Now we have to calculate the change in entropy. So here we have what values we have given. So here we have v1 v2 p1 p2. So v1 v2 we have not calculated. We know p1 p2 t1 t2. I think it should be clear that what formula we should use for entropy calculation. So I have to erase these things. So I am erasing this section. Sorry. Okay, now what is the question? Entropy change. So we know for an ideal gas we have ds equals to dH minus vdp, right? So from this relation we get change in entropy from S1 to S2 as mCp ln T2 by T1 minus mR ln P2 by P1. I hope now you are expert in these things. Just you have to put all the values and you will get the change in entropy, right? So mass is 1, Cp is how much? It is given in the question, 1.75 into ln. T2 is how much? 453.74. T1 is 300, right? So here you will get around 1 point. Okay, sorry. Okay, this is m is 1. R value is how much? 0.277 into ln P2 by P1. So this will be what? 6, right? Now solve this, we will get change in entropy as 0.02270 kilojoule per Kelvin. So this is what change in entropy. Okay, so this is the final answers. Now let's move to another question number 6, 7, 8. Okay, now let's try to solve. A constant volume tank contains 5 kg of air. Okay, so what it is given, that volume of tank is constant, right, which contains, it is given mass of air as 5 kg at 100 kilopascal. P1 is 100 kilopascal. अच्छा, जब प्रेशर अगर बार में दिया है वी हैव टू कन्वर्ट इन किलो पास्कल, और वॉल्यूम को मीटर क्यूब में करेंगे तो यूनिट कितनी आएगी यार वर्क की? इट विल बी इन किलो जूल. ठीक है, यहाँ पे ऑलरेडी किलो पास्कल में दे रखा है. इन प्रीवियस क्वेश्चन इट वाज गिवन, प्लीज चेक, लेट्स चेक. इन प्रीवियस क्वेश्चन pressure was given in bar, right? So during this the work calculation we have to take this bar in kilopascal, right? So please check this point. Okay, so in previous question actually we converted v1 equals to mRT1, so that pressure we didn't convert it in kilopascal for work calculation, right? So here it is already given in kilopascal, and T1 is 327 degrees Celsius. Just add quickly 273. We will get 600 Kelvin. The air is cooled to surrounding temperature surrounding temperature of 27 degrees Celsius, T2 is 27 degrees Celsius plus 273, this will be 300 Kelvin. Assuming constant specific heat, CV is given, and it is asking, let's try to explore what is the entropy change of system surrounding. Okay, fine, let's try to understand this question. So here volume is constant. Okay, fine. So here we have air, and it is saying that volume is constant. Okay, so now let's try to draw this thermodynamic process on PV curve. So what it is saying, pressure initially it was 100 and temperature was this much, and temperature was decreasing to 27 degrees Celsius. So what is happening here, temperature is decreasing. What does it means? That ये ठंडा हो रहा है और volume is constant, so it will be like this, right? So this is 0.1, this is 0.2, and V1 is equals to V2, correct? And this is we are assuming this as ideal gas, and it is having constant specific heat. CV is equals to this much for air, right? Now volume is constant. Now think, we have to calculate what entropy change. This is air and this is air, right? And it is cooled to the surrounding temperature. This is air is taken as system, and इसके outer में क्या है, we have surrounding temperature is how much, 27 degrees Celsius, right? So what will be the concept? So let's try to explore this. Okay, now let's try to think this question in this manner. We have two thermal reservoir. One is at temperature of 600 Kelvin. Okay, this is what air, and it is coming out to temperature of 300 Kelvin. This is what surrounding, right? So if I want to calculate ds of universe, right? So here if we take this as a universe, so this will q will be 0. So what we get as generation equals to ds of air plus change in entropy of surrounding, right? Okay, so ds of air will be how much here? Now let's try to calculate it separately. ds of air, now here this air is cooling down and volume is constant. So for calculation of this entropy for the ideal gas, we have two equation. One is TdS equals to what, du plus pdv, and one is TdS equals to dh minus vdp. Okay, so acha, tell me which relation should I have to use for this equation? ये लेना चाहिए या ये लेना चाहिए? ओके, यहाँ से जो सबसे आसान हो, जस्ट वी हैव टू कंसिडर दैट. सी वॉल्यूम इज़ कांस्टेंट, वॉल्यूम कांस्टेंट हो तो क्या होगा यार, dv की वैल्यू 0 हो जाएगी, राइट? सो TdS विल बी डायरेक्टली, ds विल बी व्हाट, ds विल बी डायरेक्टली du upon t. So du will be what, mcv dt upon t, right? This will be what, mcv dt upon t, right? So just to what we have given all the values here, just we have to integrate from t1 to t2. So we will get mcv ln t2 by t1. M value is how much, 5. CV value is how much, CV is given in the question. this is 0.718 into ln. T2 is how much? T2 is 300 and this T1 is 600, right? So just solve this, we will get minus 2.488 kilojoule per Kelvin. So this is what ds, change in entropy of air, right? हमने यहाँ पे ये इसलिए लगाया क्योंकि दिस वाज व्हाट आइडियल गैस, राइट? दिस इज आइडियल गैस. अब यहाँ पे क्या होगा, जितनी हीट एयर लूज करेगा उतनी हीट सराउंडिंग लेगा, राइट? नाउ लेट्स कैलकुलेट ds सराउंडिंग. हाउ वी विल कैलकुलेट? यहाँ पे यार क्या है, टेम्परेचर कांस्टेंट है यहाँ पे, किसका? सराउंडिंग का, राइट? बट एयर का टेम्परेचर क्या होगा यार, डिक्रीज़ होगा. जैसे जैसे टेम्परेचर डिक्रीज़ होगा वैसे वैसे इसका जो इंटरनल एनर्जी है ये भी डिक्रीज़ होगी. दैट्स वाई वी हैव इंटीग्रेटेड दिस हियर. सो नाउ so here the heat lost by the air will be equals to heat gained by the surrounding. So we will write this will be Q upon T surrounding. So this will be how much heat lost by the air. So यहाँ पे कैसे निकालेंगे यार हम? Q will be what? So first we have to calculate what will be the Q. So if we write our thermodynamic of that relation, thermodynamic first law, so du equals to del Q minus del W. So here del W will be PdV and volume is constant, so this will be 0 and we will get del Q equals to what? Du equals to mCV dt, right? So how we will get Q will be what? mCV T2 minus T1, right? So put m as 5, CV as 0.718, T2 is how much? 300, T2 is 600, sorry, and this will be 300. Let's do this calculation. We will get 1077 kilojoule, 1077 अरे यार 1077 kilojoule. Okay, so now we have delta surrounding, so this will be 1077 upon 300. So we will get this as 3.59 kilojoule per Kelvin, right? Now if we want to calculate the total as generation, this will be how much? Change in entropy of air plus change in entropy of the surrounding. So we will get what? minus 2.488 plus how much? Plus this value 3.59 kilojoule per Kelvin. So just let me remove this section. So we will get as generation as 1.10 kilojoule per Kelvin, right? Now let's check what are the answers are correct. The entropy change of the air in the tank during the process is 2.5. No, the entropy change of the air during the process is 2.5. okay, this is not, it is 2.488 kilojoule per Kelvin. Heat transfer to the surrounding is 1077. Yes, it is 1077. and entropy change of the surrounding is 2.5. Entropy change of the surrounding is entropy change of the surrounding कहाँ पे आया भाई? Entropy change of the surrounding is no, entropy change of the surrounding is this, so this is wrong. Entropy change of the universe is this is correct, 1.11, so this is correct. Okay, entropy change of the air in the tank during the process is 2.5 kilojoule per Kelvin. Okay, so this answer is correct, but what we got, it is negative sign is absent here, so this will be wrong. So final answer is B and D. So this is all for question number 8. So let's move to next question, question number 9. So this is very important question. So this is what question number 9, it is based on that type 4 for open system. Now let's try to understand this. Air is compressed by a 12 kilowatt compressor from P1 to P2. Okay, now let's draw the compressor. So compressor is a device which increases the pressure, right? So it will be like this. So what is happening here? This air is inlet. Air is compressed by 12 kilowatt compressor from P1 to P2. Now what is the power in compressor? We apply work on the compressor, so it will be what, 12 किलोवाट. टरबाइन में क्या होता है, वर्क डन बाय द टरबाइन होता है. कंप्रेसर में क्या होगा, वर्क डन ऑन द कंप्रेसर होता है, राइट. सो एयर विल कम आउट फ्रॉम दिस साइड. So air is coming from this and air is coming out at this. This is what reason 1, this is what reason 2. Okay, so this is what air out, this is what air in, and it is given that this is W dot, this is work transfer rate, 12 kilowatt compressed from P1 to P2. Okay, we will see what is P1 to P2. The air temperature is maintained at constant at 25 degrees Celsius during this process. So what is, so here this temperature is constant, so this is our system and its temperature is remain constant. So we are taking this T system as 25 degrees Celsius. This is constant during this process as a result of heat transfer to the surrounding medium at 10 degrees Celsius. So T surrounding, we are taking this infinite, T infinity surrounding is 10 degrees Celsius, right? So this will be how much in Kelvin? This will be 298 Kelvin. This will be 283 Kelvin. Okay, the surrounding medium 10 degrees Celsius. Estimate the rate of entropy change of the air in watt per Kelvin. Okay, so this is for what, compressor, and what we are assuming here, this is steady flow. What we are assuming here, this is steady flow. non-steady flow is out of your scope, out of your syllabus. So what questions we will be solving, it will be what steady state, right? So let's try to write the energy balance equation for this process. Okay, so we have learned that for this dm by dt is m dot 1 minus m dot 2. Okay, this is mass flow rate in, this is mass flow rate out. This is for mass balance. Let's write the equation for energy balance. What we were writing here, we were writing the del q dot minus del w dot, right, plus m dot 1 m dot 1 m dot 1 into g z1 plus c1 square by 2 plus h1 is what enthalpy at point 1, and minus m dot 2, the same quantity will be here, gz2 plus c2 square by 2 plus h2. This is what enthalpy, this is specific enthalpy. Okay, now it is saying that temperature is constant in this. It means T1 equals to T2. यहाँ पे temperature will remain constant. So if I write H1, it will be what mCp T1, and if I write H2, it will be what mCp T2. So T1 and T2 both are equal. So what is going to happen? H1 will be equals to H2, and here in steady state m dot 1 equals to m dot 2, right? So we can we cancel these two values? So this will be cancelled with this, right? And we are assuming that change in potential energy, the change in potential energy is 0, right? And we are also assuming the change in kinetic energy, is also 0. So these quantities are 0, and the system is in steady state, so this will be also 0. So what we will get in the end, we will get del q dot is equals to del w dot, right? और यहाँ पे del w dot, and here this is for work done by the system, और यहाँ पे क्या हो रहा है, this will be minus, right? So we write work done on the compressor. This is what work done on the compressor. So this will be minus 12 kilowatt, right? So this will be equals to heat transfer, right? And now what is the temperature of this? What is the temperature of heat transfer? T system is given as 298 Kelvin. T system is given as 298 Kelvin. So if I write change in entropy, right? Change in entropy. So what will be happen here? This will be equals to change in entropy of system. This will be what? Del q upon T, right? Because this temperature is constant, it is not varying with time, it is not varying with anything, right? Temperature is constant, so this value will be constant. And heat Q value just we have calculated from here, this will be minus 12 kilowatt upon 298. This will comes to 40, this will be minus 40.3 watt per Kelvin. So this is the what change in entropy of the air in watt per Kelvin. So this is the final answer, right? So now let's move to next question. Okay, so let's try to understand this question. Steam enters the turbine with the pressure of 30 bar and 40 degrees Celsius, right? And H value is given. So now let's make the turbine. How does it looks like? Turbine is turbine is used for work providing for expansion. So this is shaft. So this will be what work done by the system, right? Turbine, what turbine provides work, this will be what work done by the system. And here I'm taking this as a 1, this is inlet, and this is what outlet at 2, this is 1. Okay, and here now let's write all the values. Steam enter the turbine with a pressure of how much? 30 bar. P1 is 30 bar, T1 is 400 degrees Celsius, and H1 is 3230.9 kilojoule per kg, and velocity is C1 is 160 meter per second. Saturated vapor at saturated vapor at 100 degrees Celsius, H equals to this much, exit with velocity of, so it is saying at 2 we will have saturated vapor. So here at 2 we will have T2 is 100 degrees Celsius, H2 is 2676.1 kilojoule per kg, exit with velocity of C2 is 100 meter per second. Now here C2 is given as 100 meter per second at steady state, right? So I think we have discussed in our entropy formula, in steady state what is going to happen. Dm by dt will be equals to what? 0. dE by dt will equals to what? 0. and ds by dt will equals to what? 0. So you can refer to the previous lecture. So from there we will get this is for a steady state. Okay, so this is at steady state, and turbine develops a work of W. This is what work done by the turbine, develops a work of 540 kilojoule per kg. The heat transfer between turbine and surrounding occurs at an average temperature of 350 Kelvin. So how much it is showing that heat transfer is happening at average temperature of 350 Kelvin. At average temperature of this is the average temperature for turbine, right? So if I take our control volume like this, so open system, it is described, we use control volume here because the fluid is moving across this control volume. One, this is inlet, this is outlet, or inlet or exit. Okay, average temperature is this much. Determine the entropy produced, entropy generated within the turbine per kg of steam. Neglect changes. Take inlet entropy at inlet and entropy at outlet. It is also given here. So this we have S1, we have 6. So S1 is 6.932 kilojoule per kg Kelvin, and here S2 is 7.361 kilojoule per kg Kelvin. Okay, so this is open system. So in open system we have to write three equations. One is for this, one is for energy, one is for entropy. We have discussed in our, I think, previous lecture, that the entropy formula lecture. So let's write the energy conservation for mass. So this will be what? M dot 1, M dot 2. Okay, let's write this for energy conservation. What we get, del q dot minus del w dot equals to m dot 1, m dot 1 plus something minus m dot 2 plus something. Okay, so what is going to happen here? It will be 0. Here this will be 0. Let's write this section in detail. So this will be del q dot minus del w dot plus m dot 1. This will be what? gz1 plus c1 square by 2 plus h1 minus times m dot 2 into gz2 plus c2 square by 2 plus h2. Okay, so now you can see that here we have neglect changes. It is saying that you can neglect the changes. So here nothing is mentioned about height, so we will neglect this. This will be 0. z1 minus z2 will be 0. Its difference will be 0, right? So what terms we have? We have given it is given c1 is given and c2 is also given, right? h1 is also given, h2 is also given. Enthalpy at inlet, at out and at outlet, this is what h1 is given here, h2 is given here, right? So what we have to do, and you can see that work is given per unit mass, so just divide it by mass. m dot 1, m dot 1, m dot 2 is same, right? So this will be cancelled out. So we will get specific properties, and you can see here velocity is in meter per second and enthalpy it is in kilojoule, right? So just multiply it by 1000 to make this term in kilojoule, right? So this will be multiplied by 2000, right? Now let's erase this. I am erasing this. You can write in your copy and you can check the equations. Okay, so what we will get here, and we have all the values. Okay, now let's try to write all the values here. Del q, we are writing it small q, del q minus del w. Okay, this will be equals to इस सेक्शन को उधर ले जाते हैं अपन. दिस विल बी इक्वल्स टू h2 प्लस c2 स्क्वायर बाई 2000. ओके, माइनस h1 minus c1 square by 2000. I hope this is clear, and we have what work done. This del w already we have defined, it is given here. How much are 540. So just write del q minus 540 is equals to, put all the values here, h2 is 2676.1, V2 is 100 minus H1. H1 is how much? H1 is 3230 and V2 is 160. Right now do all this calculation. From here we will get del Q value as minus 22.6 kilojoule per kg. Okay, so this is what a heat transfer value. Now I'm erasing this section. Now what it is asking, determine the entropy produced, entropy generated within the turbine per kg, right? So we know as we have derived in our entropy formula lecture that change in entropy for open system, this will be how much? S2 minus S1 equals to del Q upon T plus S generation, right? S2 and S1 is given to us. S2 is 7.361 minus S1 is 6.932. Unit is kilojoule per kg Kelvin. This will be equals to del Q minus 2 to mass is 1, so we can take, so no effect will be there, and this heat transfer is happening at constant temperature, so this will be 350 plus S generation, right? So from here we get S generation value as 0.45 0.4935 kilojoule per kg Kelvin, right? Now you can see this S generation value is positive, so this process is feasible, and all the feasible process are irreversible in nature, right? So this is all for this question number 10. So this is all about subject entropy. So this is all for today.